Okay. Calculate the moment of inertia of an I section having equal flanges 30 and 10 mm and wave also 30 and 10 mm about an axis passing through its center of gravity and parallel to x-axis and y axis. Okay. So this section it is given I section beam. So its flanges it is 30 by 10 mm. So this one it is top flange and bottom flange. The size of top flange and bottom flange it is given 30 by 10 and wave. This one it is wave size. Wave size it is also given 30 by 10 mm. Okay. So this section it is given. Actually this section it is symmetrical section. Okay. So this is symmetrical I section. And symmetrical I section X bar it will be half of this. Okay. When you fold about the Y axis, the X bar it will be get 15 mm. X bar it will be get 15 mm and Y bar it will be get half of this about the Y axis. Okay. Half of this the about y-axis. Y bar is equal to, the total depth it is 10 plus 30 plus 10. So it will be 50. 50 by 2 it will be get y bar. 50 by 2. So this one it is 25 mm y bar. Okay. Because of this value it will be get because of symmetrical section. Okay. So now first of all calculate moment of inertia about the x-axis. Moment of inertia about x-axis. About x-axis. Okay. So we will calculate moment of inertia here two methods. Okay. So I will calculate first shortcut method. So just consider this is I section as a box section. Okay. This I total I section we consider it is a box section. Okay. So this one it is box section. So this is total box section. So box section its width it is B is equal to capital B is equal to it is 30 mm. Okay. And depth of this box section it is 10 plus 30 plus 10. It will be 50 mm. 50 mm. Okay. So deduct these two dimension here. So this one it is two section. Its width it is we just consider it is B1. So the distance we consider it is B1. It is B1. Calculate B1 it is B1 is equal to B1 is equal to it is so total it is 30. 30 minus this 10. 30 minus 10 it will be 20. So this B1 it will be get total it is 20. 20 divided by 2 it will be. So it will be get. So this one it is also B1. This one it is also B1. B1. Okay. So this B1 it will be get 10 mm. 30 minus 10 it will be 20. 20 divided by 2. So it will be 10 mm. B1 it will be 10 mm. B1 it will be 10 mm. Now calculate D1. D1 it is which value D1 it will be? This value it is D1. Okay. Here this dimension it is D1. So how to calculate D1 it will be? So D1. So this one it is 30 mm. D1 it will be 30 mm is equal to 30 mm. Okay. So Ix it will be calculated. Ix is equal to it will be a direct value BD cube capital B into D cube BD cube capital B into D cube divided by 12 divided by 12 12 12. So minus deduct these two rectangular portion. Okay. Minus 2 in bracket in bracket in bracket B1 B1 into B1 into D1 cube B1 into D1 cube divided by 12 divided by 12 D1 into D1 cube divided by 12. Okay. So just put all these value here, it will get Ix value. Okay. Is equal to Ix is equal to, so B it is capital B it is 30 into capital D it is 50 cube 50 cube 50 cube divided by 12. 50 cube divided by 12, then minus 2 in bracket close, in bracket, b1 it is, b1 value it is 10 into d1 it is 30 cube, 30 cube divided by 12, 30 cube divided by 12, divided by 12. Okay, bracket close, bracket close. So from this relation it will get ix value. So then ix is equal to, so first of all 30 into 50 cube divided by 12. So it will get 312.5 into 10 raised to the power 3, then minus 2 into 30 into, sorry, 10 into 30 cap 3 divided by 12. So this one it is 45 into 10 raised to the power 3. 45 into 10 raised to the power 3. So from this relation it will get ix value. I will write down ix value here. Ix is equal to, write down ix is equal to total moment of inertia is equal to ix. So 312.5 into 10 raised to 3 minus 45 into 10 raised to power 3. It will be 267.5 into 10 raised to the power 3 mm raised to 4. This is moment of inertia for I section, Ix. Moment of inertia about the Ix for symmetrical I section. Okay. Then second one it is calculate now Iy1. Moment of inertia about the Iy1. Okay. Just calculate now. Moment of inertia about Iy1. Moment of inertia about y axis, about y axis, okay, about y axis. So now calculate Iyy is equal to here Iyy1 plus Iyy2 plus Iyy. Okay. So here it is Iyy now. So this section it is passing through all the rectangle parts. Okay. So we divided it is in 3 parts. Okay. This one it is first, then this one it is second wave, and third one it is top flange. Okay. So write down Iyy is equal to so first Iyy1 for first it is dB cube by 12. Here dB cube by 12. So d it is here 10. D it is 10 for bottom flange. D it is 10 and B it is 30. 10 into 30 cube. Divided by 12. Divided by 12. So actually top flange and bottom flange value it will be same. Okay. 30 into 10 raised to the power 3. You can say it will be directly into 2. So Iyy3 and Iyy1 it is same. Then second one it is wave. Here it is dB cube by 12. So d it is here 30. D it is here 30 for wave. 30 into 10 cap 3. 10 cap 3 divided by 12. Divided by 12. Divided by 12. Okay. Divided by 12. So here I will again explain. dB cube by 12. D it is here 30 and B it is this 10. B it is 10. So that's why dB cube by 12. D it is 30 into 10 raised to 3 divided by 12. Okay. For flange dB cube by 12. So D it is here 10. Work flange D it is 10 and B it is 30. Where this distance it is 30 mm. Okay, so that's why it will be 10 into 30 cube by 12. So same for top flange it is also. That's why I multiply by 2. dB cube by 12. D it is here 10 and B it is 30. So dB cube by 12. So that's why I have multiply by directly twice. Okay, so now is equal to 10 into 30 raised to 3 divided by 12 into 2. So this one it is 45 into 10 raised to power 3. 45 into 10 raised to the power 3. Then plus 30 into 10 raised to the power 3 divided by 12. So this one it is 2.5 into 10 raised to the power 3. 2.5 into 10 raised to the power 3. Okay. So total IYY it will get from this relation. IYY is equal to 45 into 10 raised to the power 3 plus 2.5 into 10 raised to the power 3. The total moment of inertia 47.5 into 10 raised to the power 3 mm raised to 4. So this one it is IYY. This one it is IYY. This is your final answer. So this is IYY. This one it is IXX. Okay, so we have calculated IXX and IYY. Well, right here, X it is XS is equal to it will be 312.5 into 10 raised to the power 3 minus 45 into 10 raised to the power 3. So this is 267.5 into 10 raised to the power 3 mm raised to 4. So question was calculate the I-axis and IY. Okay. So this one it is I-axis and this one it is IY. Okay. This one it is I-axis. Moment of inertia about the I-axis it is 267.5 into 10 raised to the power 3. Okay. So this one it is 10 raised to the power 3. I-axis is equal to 267.5 into 10 raised to the power 3 mm raised to 4. 4. This is I-axis and this one it is I. Okay. So I-axis it is 267.5 into 10 raised to power 3 and our it is 47.5 into 10 raised to power 3 mm raised to 4. So this is moment of inertia for symmetrical I section. Okay.